Good morning. Hope you're doing well today. Might actually be afternoon or evening. Whatever it is, hope you're having a fine day. And it's now time to learn about similar right triangles. Um, so, in this lesson, we're looking at how an altitude affects triangles that get created. So you're starting out with the right triangle, and you're dropping an altitude going from the hypotenuse to one of the vertices here. Okay, so the altitude, remember, is a perpendicular segment that goes from a vertice to the opposite side. All right, so when you have a right triangle, the altitude actually creates three similar triangles, okay? The reason why they're similar is because, well, all the triangles now have right angles, so that's one angle, okay? And the one triangle shares angle A, so look here, you have angle A that's shared. Okay, so by angle-angle similarity, we know that the smaller triangle is similar to the bigger triangle. And the other triangle shares angle B, so the medium-sized triangle is similar to the larger triangle. And since the one is similar to the one and the other one similar to the same one, we could combine them and say, da-da-da-dum, Theorem 7-4, triangle CAB is similar to triangle DAC is similar to triangle DCB. Okay, so the small is similar to the medium, is similar to the big, and they're all similar to one another, which allows us to find a lot of missing sides. So that's what we're doing in this lesson, finding a lot of missing sides. All right, so that's the main idea of the whole entire lesson here. Okay, so we're finding missing sides within a right triangle. So here you're given a right triangle. You know some of the sides. We're looking for side QS. Okay, so oftentimes you want to figure out, okay, you know that all three triangles here, because there's an altitude and it's the right triangle, are similar to one another. So you have to pick two of the three triangles to use, all right? So let's use, okay, now you could probably do this one a couple different ways because you know a lot of information here. Okay, so let's think about it. From the small triangle, we know two sides. We're missing the third side, okay? And actually, you could probably use the Pythagorean theorem and find QS right away, but we're going to do this problem a different way using similar figures, okay? Which is kind of funny. All right, so we're just going to roll with the way that they did it and use the small triangle and the big triangle. Now, if you try to do it the other way and you find that it works, great, okay? Sometimes you pick two triangles, you set it up, and you realize, oh, I'm missing too much information. I should pick the other two triangles. All right, let's go ahead and write a proportion then. Remember, similar triangles are proportional. So that's all that we did in the last lesson, basically. All right, so we're finding QS. So what would our proportion look like? All right, so take the small triangle and then orientate the big triangle to be in the same direction of it. Okay, so let's see which side goes with which one. Okay, so QS goes with PQ. Okay, so PQ is equal to 20. So our proportion would be QS over 20, okay, is going to be equal to the ratio of, now let's see, which side do we know? We could do QR, but we don't know PR, so we can't do that one. So we went from the small triangle to the big triangle. So on the other side, we're going to go small to big as well. So that would be 9 to 15. So we're going to go 9 to 15. Okay, then you're going to do cross multiplying to solve this here. Okay, so we're going to go ahead and cross multiply to solve this. Remember, in between a proportion, what makes it a proportion is an equal sign. Okay, so we're going to do cross multiplying. So we have 15 times QS. So I'll just put 15 QS is equal to 9 times 20. 9 times 20 is 180. So QS is equal to 180 divided by 15. And for those that can't do that real quick mentally, which I can't do it either, I'm just picking up my calculator right now. So QS is going to be equal to 12. And just make sure that makes sense there, because you don't want to have QS be bigger than your hypotenuse, because QS is the second largest side and the hypotenuse is the largest. All right, and that looks good. So there you go. All right, let's try to do another one here. It's a bit tricky here. We know we're looking for PS, okay? In order to do this one, I actually had to do it a couple times. I realized that you need to use QS from the prior problem, otherwise it's impossible to do, okay? So you need to find, I had to write this number 12 in here, which was QS from the prior problem, all right? So in order to do this one, to find PS, we need to first figure out which two triangles to use. Now, you could use actually any of the three, and it would work out because we have enough information once we realize we've got to use QS from the prior problem. So let's use the two smaller ones, okay, inside the bigger one. So it's a good idea to orient your triangles to be in the same direction. So I took the small triangle and I rotated it 90 degrees so that RS, which is, there it is, okay, RS is now facing top to bottom before it was on the bottom, okay? And the hypotenuse 15 is now facing the same way as QPS, all right? So remember, we know that QS is equal to 12, so let's make sure to label that. Whoops, go back there. Let's make sure to label QS being 12. So we got QS is 12. All right, now since we know that, we could figure out what PS is. Now, we could actually figure out PS by using the Pythagorean theorem, but in this lesson, we're not going to be using the Pythagorean theorem unless we absolutely have to. So we're going to try to figure out these problems with similar figures, okay? So we're finding PS here. So let's write a proportion. We're looking for PS, so I'm going to put PS here, which is the one we're looking for. I always like to start with my variable, the one that we don't know, in my proportion, just to make sure that gets in the proportion. So we're going from the bottom of the medium triangle to the bottom of the small triangle. So it's PS to 12, okay, is equal to, now, you have a choice which way you want to do this. You could use either the hypotenuse, or if you want to, you could use the height of the triangle here. But I'll just use the hypotenuse just to be clear. So we got 20. Okay, we're comparing one hypotenuse to the other hypotenuse, 20 to 15. Now you could do 12 to 9 if you wanted to, and that would work just as well. Okay, so let's do cross multiplying. So we have 15 times PS. To figure it out, we'd had 15 PS. All right, it's equal to 20 times 12, which is equal to 240. All right, and now if we divide both sides by 15, 240 divided by 15 is equal to 16. So there you go. PS is equal to 16. And that's all I'm going to do in this video. Just one quick note before I wrap things up here. The reason why you could also use 12 to 9 is because the ratio 12 to the 9 is the same thing as 20 to 15. They all reduce down to 4 to 3. Okay, divide 20 by 5, you get 4. Divide 15 by 5, you get 3. You could divide 12 ninths, divide by 3. On top and bottom, you get 4/3. And since they're the same ratio, and they will always be the same ratio because it's proportional, because they're similar figures, it doesn't matter which sides you pick if you know that, as long as you know both sides, okay? So there's different ways you could do these ones. You just pick whatever you feel simpler. In the end, it still works out to the same number for PS. All right, hope you guys have a great day. Take care now.